Hello Gems, welcome to a brand new series which is the Super 30 series. In this series with every video we are targeting 30 most probable questions for BITSAT 2024. So this series is going to go on for a while, about 2-3 months, and by the end of this series you will have 300 most probable questions for BITSAT 2024. So if you are interested in that, subscribe and join for free. Okay, so with that being said, let's begin with session 1 of this series with question 1 and 2 over here. In question 1, suppose the law of gravitational attraction suddenly changes from your inverse square law, which is F proportional to 1 over r square, to an inverse cube law, which is F proportional to 1 over r cube. Okay, so it changes its form. So you are supposed to tell which of the following law will still hold, which of the following law will still be the same. Is it the law of area, law of periods? Is it both of them, or is it neither of them? Okay, the key point over here is that the force remains central. Okay, so since the force is central, it is directed towards the center. Okay, since it's attraction, it's towards the center. Okay, it can be towards or away, central force, but here it is attraction, so it is towards the center. Okay, so from central force you can actually say that since for central force we have your angular momentum constant, right, or conserved. Okay, this is a property of central force. So for any central force, angular momentum will always be conserved. So from here you can actually say that the areal velocity is constant, right, or the law of areas hold, because from angular momentum itself you derive the areal velocity, and that the areal velocity is constant. If you derive it, it will be dA by dt is L by 2m. Okay, the constancy of your areal velocity is a result of conservation of angular momentum. Okay, so the correct option over here is that Kepler's law of area still holds. This law of periods will not hold because this law depends on your r, okay, a cube or r. Since the force relation is changing, this law will also get modified. Okay, the law that holds over here, since the force is central, is the law of areas. Okay, so option A is the correct choice over there. Let's come to question 2. Here we are supposed to use simple error analysis. We are given the equation Q is equal to I square RT, heat equation. I is current, R is resistance, T is time, you might know, and the percentage errors in each of these quantities are given 2%, 1%, 1% in IRT respectively. You are supposed to find the maximum percentage error in heat. Okay, so Q is equal to I square RT. You can use simple error analysis. Since this is multiplication, you are supposed to add relative errors or add percentage errors, right? So the percentage error in Q, which is delta Q by Q, and I'll write in percentage, so I'm not writing into 100, it is understood, it is multiplied by 100. So this is I square, right? So the power will come down and will have 2 times the error in I. Okay, the percentage error in I plus percentage error in R, so simple error analysis, and the percentage error in T. Okay, so if you know the concept for BITSAT, it's very easy to solve the question. So this is directly based on your error analysis. So this is 2, and percentage error in I is 2%, right? I is 2%, this is 1, and this is also 1, T is also 1. So 2%, here R is 1%, and T is 1%. Okay, so this is 4, 5, and 6. So 6% is the maximum error that can occur in the measurement of heat. Okay, so option D, 6% is the correct choice over here. Over to the next set of questions. 3 and 4 over here. Actually, I cleaned my board with sanitizer, Q-chalk gaye, but it still smudges. Okay, let's not worry about that. Let's come to the questions. Question 3, an alternating current, an alternating voltage, which is V naught sine omega t, is applied to a circuit which results in a current I is equal to I naught sine omega t plus pi by 2. So the current is leading by pi by 2. I think capacitor circuit, right? Voltage lags, current leads. Okay, so flows in it, the power consumed per cycle. So for purely capacitive circuits, you might know that the power, you might directly know that the power consumed is 0, right? Or why it is 0, you can see that the relation for power is not basically VI, it also includes a power factor, right? VRMS, IRMS into cos phi. Phi is the phase angle, phase difference, okay, between V and I. Okay, so if you see phi over here is here VRMS and IRMS is root 2 times the 1 upon root 2 times the peak value. So V naught by root 2, I naught by root 2. Okay, those are the values of RMS voltage and current. Okay, here phi, if you see the difference in the phase omega t, the difference is pi by 2, and cos pi by 2 is cos 90 is 0. Okay, so this term power becomes 0. Okay, cos phi is 0, cos 90 is 0, so the power is 0. Okay, since it's a purely capacitive circuit, it dissipates no power, right, in AC. Okay, so the power is 0 in this case. Okay, simple formula you're supposed to know. Let's come to this. Here we have IV characteristics given below, the plot of current versus voltage for a particular device. You are supposed to guess what is that device. Is it a ohmic device, follows Ohm's law, non-ohmic device, violates Ohm's law, insulator or superconductor. You can clearly see the plot is not linear, right? It's not linear. Okay, so for an ohmic device, the plot is, so if you have the IV characteristics, or I should say VI characteristics for an ohmic device, you will get a linear graph, right? And the slope of this graph R is equal to V by I, gives you the resistance. Okay, this is true in Ohm's law. Now, for devices that follow Ohm's law, we have a linear plot between V and I, and the slope will give you V versus I. If you have, then the slope will give you the resistance. Okay, so clearly you can see that this plot is non-linear. Okay, it is not following the Ohm's law, so it is non-ohmic. It's not ohmic. Okay, if it was ohmic, then we'll have a linear plot. It's not ohmic, then hence we don't have a linear plot. The I and V are not varying linearly with respect to each other. It's not an insulator. For an insulator, the current would have been 0 irrespective of the voltage, ideal insulator. And for superconductor, current would have been just like shooting up for even a small voltage. Okay, so it's the correct answer over here will be option B, non-ohmic, non-linear characteristics between I and V. Okay, so that's about question 3 and 4. Over to the next questions. Question 5 and 6 over here. In question 5, we choose force, length and time as the fundamental units instead of your mass, length, time. You are supposed to tell the dimensions of mass in this system. Okay, the smart way of doing this is to substitute force in each of these equations, okay, in each of these dimensional formula in terms of ml to the power minus 2, and see which option will give you mass. And the standard way, we'll do it by the standard way. You can try it the other way around. The standard way is using your dimensional analysis, m proportional to f to the power a, l to the power b, and t to the power c. Okay, here you'll have dimensionless constants. So if you take dimension, it doesn't really matter. You can basically write f raised to a, l raised to b, and t raised to c. Right now, the dimensions on left hand side, m1, l0, t0. Right, we'll just equate the dimension on both the sides. Here we'll have m l t raised to minus 2 raised to a, right, force is mass into acceleration. Then we have length, basically l, raised to b, and t raised to c. Okay, now take the powers together, m only one m, which is raised to a, l we have l raised to a, l raised to b, so that will be l raised to a plus b. Here we'll have t is raised to minus 2a, and here plus c. Right, now you can equate the dimensions. Okay, so you'll get, if you equate the dimensions of m, you'll get a is 1, then l, if you equate, you'll get a plus b is equal to 0, which means b is minus a, which is b is minus 1, right, b is minus a, b is minus 1. And here we'll have minus 2a plus c is equal to 0, minus 2a plus c is equal to 0, and that will give us c as 2a, c is 2 times of a, which is 2, right. So your mass is nothing but f raised to a, which is f raised to a1, l raised to minus l raised to b, which is minus 1, t raised to c, which is 2. Okay, so f l t raised to 2, f l t raised to minus 2, f l t raised to 2, option B. Okay, f l, f minus l, f1, l raised to minus 1, t raised to 2. Yes, I get it now. Let's come to question 6. Here we have been given the instantaneous displacement of your SHM motion. It is given as this: x is equal to a cos omega t plus pi by 4. You are supposed to tell at what time will its speed be maximum. Okay, so this is a displacement, right? We can find dx by dt, that is the velocity. Okay, velocity or speed if you just consider the magnitude. So here we'll get, if you differentiate this, we'll get a as it is. A differentiation of cos is minus sine, right? Minus sine omega t plus pi by 4. Since we are differentiating with respect to t, you will have to use the chain rule and differentiate omega t, that will give you omega, right? So we are supposed to find the maximum speed. So speed will be maximum when the sine term is maximum, right? V max will be a omega, right? We don't plus or minus a omega, we don't worry about the sign since it is speed, right? Speed is value only, okay? We don't matter, the direction does not matter, okay? So this will be maximum only if you have sine of omega t plus pi by 4 as 1, okay? Which means omega t, this angle will be 90 degree, right? Sine of 90 is 1, so this angle is 90 degree, okay? Pi by 2. So pi by 4 is 45, this is 90, 90 minus 45 is still 45. So omega t is 45, okay? Omega t is 45, meaning t is pi by 4 omega, pi by 4 omega, okay? Which is option A, okay? So at that time the speed will be maximum, okay? So we just reversed it, okay? Max speed, we should have this as equal to 1 and then solved it for t, okay? That's about question 5 and 6. Over to the next set of questions. Question 7 and 8 over here. In question 7 we have the interference experiment, which is the YDSA experiment. We are told that at a point 1/4 of the maximum intensity appears. You are supposed to find the angular position of that point, okay? So for interference, the relation in the intensities, you will know it. It is given as I is equal to I naught cos square phi by 2, right? Phi is the phase angle. So from there you can find the phi, and from phi you can find the angular position, okay? We'll do it step by step. So here the intensity at that particular point is given as 1/4 of the maximum intensity. Here I naught is the maximum intensity, so I is I0 by 4, okay? So that will get cancelled and we'll get cos square as 1 by 4, cos square phi by 2 as 1 by 4. So basically cos of phi by 2 is half, right? Cos of what is half? Cos of what angle is half, I mean. So cos of sine of 30 is half, cos of 60 is half. So this phi by 2 should be equal to 60. We can write it in radians. Radians it will be pi by 3, right? So that will give us phi as 2 pi by 3, okay? So the angle is, phase angle is 2 pi by 3, okay? Now important relation is that for a complete 2 pi phase will have lambda, right? So 2 pi corresponds to lambda. 2 pi will entirely give you lambda, the complete wavelength, right? So now we have 2 pi by 3. 2 pi by 3 will give us lambda by 3, okay? So this is important because from here we can find the phase relation. So you can see it is between lambda and d, right? So the angular position is basically, you will get it as sine theta, or Bragg's law you can say. From there you get the angular position. So you can say d sine theta is equal to delta x, the part difference. Here for 2 pi phase difference we have part difference of lambda. For 2 pi by 3 we'll have lambda by 3. So in our case the part difference is lambda by 3. So I am using delta x is equal to d sine theta, okay? So in our case delta x is lambda by 3, okay? And from here you can easily see that this theta will be, d will go down, so we'll have lambda by 3d, and theta will be sine inverse of lambda by 3d, okay? Which is option C, okay? So that is the correct choice, and this is the proper way of doing it, okay? Let's come to this. This is a very simple one, okay? I don't know why this is a BITSAT question, but yeah, let's do it. So here we are given the equation of trajectory of projectile motion, and we are supposed to tell what is the angle of projection, okay? So if you know the equation of trajectory, the question is done, okay? Because if you see equation of trajectory, it gives x tan theta into, you might remember that form, 1 minus x by r, or you can remember the long form, which is x tan theta into g x square upon 2u square cos square theta. Okay, so if you compare these two equations, you can clearly see that the coefficient of x, if you can compare, it will be, here coefficient of x is tan theta, and coefficient of your x in this equation is root 3. So tan theta is root 3, and they have given this as an option. They might have also given the tan theta or theta as 60 degrees, so that would have been the correct choice because tan of 60 is root 3, right? So in this case they have directly given tan theta is root 3, so that is your answer. You just had to compare the two equations, equation of trajectory with this given equation. Okay, so that was very simple. Let's move to the next question. Question 9 over here, we have a freight car moving along the horizontal, so 1D motion with this speed, and it strikes a bumper spring coil. Okay, so this is a mechanism made to stop that cart. So we have a spring, it will hit that spring with this speed, and basically the spring will compress a certain length and make the cart stop. Okay, so the maximum compression the spring experience is 30 centimeter in stopping the cart. So when the compression is 30 centimeters, the spring will stop the cart. Okay, and the mass of the cart is given, or the car. The elastic potential energy of this spring is asked at the instant it is compressed by 15 centimeters. So what is the potential energy at the instant when it is compressed by 15 centimeters? Okay, so we are supposed to find half kx square, right? And x is 15 over here. We are supposed to know the value of k from the initial conditions. Okay, that the spring stops the freight in 30 centimeters. Okay, so for that we can use conservation of energy, right? So half mv square, this energy, which is the kinetic energy of your cart, will be converted completely into potential energy of the spring when it is compressed by 30 centimeters, because 30 centimeters, at 30 centimeters the kinetic energy is completely stopped, right? Kinetic energy becomes 0 and it is now transferred in as potential energy to the spring. Okay, so half mv square will be half kx square at x is equal to 30. Okay, so half gets cancelled, and from here we are supposed to find k and substitute k over here. Okay, so m is given as 3.628 v square. Velocity, actually we can convert this first, 7.2 kilometers per hour. If you want to convert it in meters per second, that is, you have to multiply it by 5 by 18. Okay, so I think this is Forza, so 0.4 into 5, 4 5 are 20, right? So 2 meters per second. Okay, so 2 into 2 divided by you can say x square, right? So I am finding the value of k, I have to divide by x square. X square is 30 centimeter. 30 is the total compression. Okay, so what will this give us? If you calculate this, this is about 9 and this 3 will cancel about. Okay, and 3 4s are 12. Actually the answer that you get is around 161. Okay, and we also have the power of 10 to the power 4. Okay, so if you consider all that, the answer that you will get is 161.24. Okay, Newton per meter, right? This is the spring constant, and now you just have to substitute it over here to 161.24 times x square. We are supposed to find the potential energy when compressed by 15 centimeters. So 15 into 15 into 10 to the power minus 4 centimeters square. Okay, that's why I am using 10 to the power minus 4. Okay, and if you compute this, this will come out to be, you can verify it in the comment section. I think I get 1.81 joule. Okay, please verify this in the comment section. Okay, I think the answer should be 1.81 joules. Okay, let's come to this question. We have an adiabatic process. The pressure is increased by 2.3%, 2 by 3%. If gamma is given as 3 by 2, the volume decreases nearly by. Okay, so for adiabatic process, we know that PV gamma is constant. Here you can use the concept of error analysis, or you can take a log and then you can take the differentiation. Basically that becomes error analysis, right? So if you see, we can use error analysis. We can see that the relative error in P, or the percentage error in P, plus gamma times, gamma is the power, it comes down, percentage error in V will be the percentage error in constant. Now constant is a constant, right? There is no error in a constant. Okay, what is the error in the value of pi? Nothing, 0, because pi is constant. It is very defined. It has infinite number of significant figures. Okay, so a constant does not have any error associated with it. We know it for sure. Okay, so the error in constant is 0. So that is the only concept you need over here. So percentage error in P, it is increased by 2 by 3%. Okay, now gamma is 3 by 2, and we are supposed to find the percentage decrease in your volume. Okay, now be careful, it's not 1. If you see, it is 2 by 3, and here we'll have 3 by 2, or I can say, I can take this to the other side, we'll have delta V by V in percentage, right? So it is minus 4 by 9, minus because increasing pressure will decrease volume. Okay, so minus 4.9% approximately. Of course, error analysis is very approximate. Okay, so they also want approximate answer nearly by, right? So your error in V will be about 4 by 9%. Okay, it decreases by, so that's why the minus sign. Okay, so that is about question 9 and 10. Let's move to the next set of questions. 11 and 12 over here. In question 11, we have two steel wires and we have a transverse wave which is traveling through them with the same frequency. The diameter of A, let's write that, the diameter of A is given as 2 times the diameter of B, and tension in string A is given as half of that in string B. Okay, so now you are supposed to tell the ratio of the velocities in A and B. Okay, the ratio VA by VB. Okay, so basically the general formula for your velocity of transverse wave is T by mu, right? Mu is mass per unit length, right? So let's substitute that. So T, mu is mass per unit length. So m by L. So that will go in the numerator. So if you see over here in the question, we are given tension. Not that kind of tension. Every question is a tension. No. So tension force is given in the question. We don't need this length. Okay, we need diameter. Let's see what we can do about that. We are told that both of them are steel wires, right? Steel wires meaning same material, same density. Okay, so we'll see if we can introduce density over here. Density is, if you see, density is mass by volume. Okay, basically because density is a constant, we want to introduce this. So we'll divide the numerator and denominator by volume. Okay, so mass by volume in the denominator will give us density. Okay, this is density, or you could have just said mass is density into volume. Okay, that can also be done. Mass is density into volume. That is the change that we have made over here. Okay, now volume can be expressed as area into length, right? So these wires will be cylindrical, so the area of the cross section times length. Okay, so we are introducing area because we are given the diameter, we don't want the length. Okay, so we want to cancel this length factor. So volume is area into length, and we have density, length cancel, and we have under root T by rho A. Okay, new formula. Okay, so if you see, area is proportional to diameter square, right? So we can basically get this out of the square root sign. We can see that this is proportional to, so the velocity is proportional to T by this will be d square. Area is proportional to d square, right? So we can say it's simply d, okay, out of the square. Okay, I hope that is clear. So finally we reach over here. We are supposed to find VA by VB, VA by VB. So that will be, we can use this relation, square root, it is proportional. So VA will get TA in the numerator, DA in the denominator, right? And for VB in the denominator, it's inverse of that. So DB in the numerator, inverse relation, and this is direct relation with tension. Direct with tension, inverse with diameter. Direct with tension, inverse with diameter. Okay, so now substitute the values. TA is, so I'll keep TA as it is. Yes, I'll substitute TB. Okay, diameter of B is given, so diameter of A is 2 times of diameter of B, right? So diameter of B over here, and I'll substitute this TB in terms of, now DA is substituted in terms of DB, and TB also I can substitute in terms of TA. So TB will be 2 times of TA, right? This and this will get cancelled, this and this will get cancelled, and you will get 1 by 2 root 2. Okay, so 1 is to 2 root 2. Option C is the correct choice over here. Okay, I hope the approach is clear. You can rewind and go through it again if it's not. Okay, so let's come to this one. We have a plane electromagnetic wave which is incident on a surface, and the energy transferred is E to the surface, and it is of course perfectly reflected, ideal case. Okay, and so E energy strikes the surface in time t. A is the area of the surface. You are supposed to tell what is the force exerted on the surface, right? Force is rate of change of momentum. Okay, and you know that radiation carries momentum. Okay, even if you don't know any of this concept, you can do it by sheer smart work. Okay, you can find the, if you see the options over here, the force will not be zero, of course it is transferring some momentum, so there will be force. Okay, so if you see each of this option A, B, C, you can see that each of them differ by some term, right? You can use dimensional analysis and you can see which of the dimensions of this option match with that of force. Okay, only one will match and that will be your answer. Okay, we'll do it by the actual concept. You can use the smart work and get to the answer. Okay, so we want force. Force is a rate of change of momentum, or average force is delta P by delta T, right? So time interval is T, you know that. If you want to see delta P, every radiation carries your momentum, which is E by C, right? Because it has magnetic field. There are many reasons for that, majorly magnetic field. So basically, if you don't know, every radiation, electromagnetic radiation, will carry momentum with it. Okay, so which is given by E by C, although it has no mass, right? That is something interesting. So E by C will be transferred to the surface, and it is also reflected E by C in this time t. Okay, so momentum is E by C, and again minus E by C. Okay, is this 0? No, because we want change in momentum. Changes final minus initial. So this minus this. Okay, so that will give us 2E by C. Okay, so this is the change in momentum, and the time is t. So 2E by C time t, that will be our answer. Okay, so option C. Okay, you can see that E by C is momentum and t is time, rate of change of momentum, force, right? You can verify it by your dimensional analysis. This will give you dimensions of momentum. This will be some by area. This will be pressure, I think, right? This is force, then this will be pressure. Okay, you can verify that. This is the actual way of doing it. Over to the next question. 13 and 14. Question 13, we are given a body of weight 2 kgs. Okay, it is suspended as shown using two strings, T1 and T2, and this also another string. So the tension T1 in the horizontal string, that is what you are supposed to find. You are supposed to find the value of this T1. Okay, here it will be T2, although it was not given in the question, but those are two different strings. Okay, for a different string the tension is different. Okay, so here you can see that it is balanced system. The system is in equilibrium. A question based on equilibrium: keep calm and balance the forces. Okay, so that is what we are going to do over here. So we can resolve this T2 along the perpendicular direction and along the horizontal direction. So you can see T2 is along this direction, and this perpendicular direction is opposite to theta. Opposite to theta, sine theta. Okay, opposite to theta, remember that opposite to theta is sine theta. So in the perpendicular direction we'll have T2 sine 30. Similarly, in the in the horizontal direction we'll have T2 cos 30. Okay, so we have resolved this T2 into T2 sine 30 and T2 cos 30. Here we will have T1. Okay, so there is no horizontal motion, so these two should cancel out, or I can write as T1 is equal to T2 cos 30. Okay, so from here I am supposed to find the value of T1. Okay, so for that I need T2. You can see that T2 sine 30 is in the upward direction, and this mass mg is in the downward direction, 2 kg weight, right? Kg weight basically means kg, this 2 kgs into g. Okay, acceleration due to gravity. So 2 kg weight only I'll write, because we want the answer in kg weight only. So let us find T2 using the second equation. 2 sine 30, T2 sine 30 is equal to mg. Mg is 2 kg weight, right? So sine 30, if you see, is half. Okay, so half, and it will go to the other side, and we'll get T2 as 4. So T2 is 4 kg weight. So we get T2, we can find T1 using this, right? So it's very simple. Okay, so T1 is what is this? 4, right? T2 is 4, and cos 30 is root 3 by 2. This and this will cancel and we'll get 2 root 3, which is option C, right? Option C, 2 root 3 is the correct choice over here. Okay, so keep calm, balance the forces and get your answer. And let's come to this one, 14. Here we have a balloon which is rising vertically upward with a velocity of, so hot air balloon, artistic. Okay, we are going to drop a stone from it with the balloon is moving with a velocity of 29 meters per second. Okay, since you drop the stone, okay, you just release it from the balloon, it is going to maintain that velocity, right? Because there is no external force on the system, you just release it, right? Release, then no external force, no change in motion. Okay, so it will continue with this. Only difference is that it has an acceleration on it. Now the stone will have an acceleration on it of minus g, right? So a is equal to minus 9.8. Okay, whenever it is not given in the question, okay, so please take, whenever g is not given as 10, please take the value as 9.8. Okay, then we are supposed to find at what height was the stone released. Okay, at some height the stone is released and it takes 10 seconds for the stone to reach the ground. Okay, so when you release the stone from the hot air balloon at a certain height, okay, it takes 10 seconds for the stone to reach the ground. Okay, for an observer on the ground it will go up first because it started with 29 meters per second, so it will go slightly up and then fall down. Okay, so you are supposed to tell the height. Okay, now it's very simple, you are just supposed to use s is equal to ut plus half at square. Okay, now s is displacement, this works because s is displacement. Okay, since the stone for the observer will go up and then come down. Okay, but the s will only give you the shortest distance between the 2 points, which is this point, the point of release, and the ground. Okay, for 10 seconds, right? It is the initial point and this is the final point, the difference between initial and final point. Okay, shortest distance. So here we have t, for t is equal to 10 seconds, we can plug in all these values. This is your initial velocity, so u is equal to 29 and t is 10 plus half, a is minus 10, a is not minus 10, I just now told you it's 9.8. Okay, you can take it minus 10, you will get a slightly different answer, it will be about 200. And here you will get t square, which is 10 into 10. Okay, so this is simple. S will basically give you h, right? I explained you, it is the shortest distance. So here you will get 290 and here what will you get? This will be 4.9, 490, right? Minus 490, so that will be minus 200. Minus basically because we are measuring from this point to this point. Okay, it's in the downward direction. We have considered the downward direction as negative. A is considered as negative, so downward direction is negative. U is considered as positive. Be very careful about the signs that you use. Okay, the conventions that you use. Upward is considered as positive, downward is negative. Okay, you can take it the other way around. The answer will be 200 meters. Okay, we are asked of the distance, height, distance, so we don't consider the sign. Okay, so that's about question 13 and 14. Over to the next question. 15 and 16 over here, so we are halfway there, 15 more questions to go, and just stick with me, let's get this done. Okay, so here we have question 15. In this we have two inductors as shown in the figure. They are connected in parallel. Okay, varying amount of current flows, I1 and I2 in them. You are supposed to tell the ratio of I1 by I2 at any instant t. Okay, it's very simple because you can see that they are connected parallelly, so E across them, E1 will be equal to E2. EMF, or I can say voltage across them is the same. They are connected in parallel, right? Now how is the voltage across your inductor given? The formula is L di by dt. So in the first branch we'll have L1 actually minus, so L1 di1 by dt, right? And similarly minus L2 di2 dt in the second branch, right? Now you can remove the minus sign, you can also integrate. Integration will give you di1 by dt will become I by t. Here also I1 by t1, I2 by t2 at a particular time t, right? So you will get L1 I1 is equal to L2 I2. This is on integrate. Okay, so you can easily see from here that I1 by I2, they are in inverse relation. will be L2 by L1. Very simple. Option A. I1 by I2 is L2 by L1. You can remember this as a standard result. Okay. Speaking of standard result, this is also a standard result. I think this appeared in JE, then it came to BITSAT. Okay, in the recent years. Here you are supposed to tell at what angle theta does the maximum height achieved will be equal to that of the horizontal range. Okay, so the H max and R are same in this case. You are supposed to tell at what angle does this happen. Okay, so basically you have to equate the formula of H max and R, and from there you can find the theta. H max is u square sine square theta by, please remember all this formula H, R and T. These are very important as far as your BITSAT is concerned. Okay, u square sine square theta by 2g for H and u square sine 2 theta by g. Okay, so u square can cancel, g and g can get cancelled. Here we will have sine square theta by 2, and here sine 2 theta we can write it as 2 sine theta cos theta. Okay, so basically we are solving for theta now, and we will have, okay, nothing in the denominator. Here this can get cancelled. You can see this will be sine theta by cos theta. That will give us tan theta, and this 2 we can take to the other side. So you can remember this as a standard result for equal H max and horizontal range. Theta should be tan inverse of 4, which is option B. Okay. So that's question 16. We are halfway done, and slightly easier part from now on remains in this session. So let's get that done. 17 from the chapter fluids. So in 17 we have a block of wood that floats in water with 4/5 of its volume submerged. So 4/5 is inside the water and 1/5 is above the water. Okay, let's consider the volume as V0. So 4/5 of V0 is inside and 1/5 is outside. Okay, the same block just floats in a liquid. So this is the case of water, and in case of some other liquid it just floats. Okay, so it's actually completely submerged in the liquid. Okay, so first of all you can conclude that this liquid is less dense, right? So water can support the weight of the block. For the same block, the block sinks more meaning this liquid is less dense than water. Water is 1000 kg per meter cube, right? So you can disregard this option. You are supposed to find the density of liquid, so it cannot be greater than 1000, right? Since the block sinks more, same block sinks more, we can say that this liquid is less dense than water. Okay, actually the shortcut way of doing this is 4/5 times the density of water. Okay, 4/5 times density of water, so 4/5 of 1000, so that will be 200 into 400, so 2 into 400, which is 800. Okay, or we'll do it by the actual concept. So here mg, your weight in the downward direction, is supported by the upthrust. Upthrust is given as V immersed, the volume which is immersed inside, rho into g, right? Rho of the liquid. So V immersed is 4/5 of 4 V0 by 5, we can say, that is the immersed volume. Rho of water, so rho of water will write, and g, right? We can actually cancel g on both sides, so we'll get mass as this, mass of the block. Okay, so similarly we can say mg is equal to upthrust is equal to volume immersed. Now in this case volume immersed is the total volume, right? It just floats, so it goes inside completely, and then the density of the liquid. Okay, in this case we have water, and in this case we have liquid, and g can cancel out, so we'll have m as v0 rho L. Now you can just equate this two, so you will get 4/5 of V0 rho of water is V0 rho of liquid. Okay, so V0 cancel, so rho of liquid is 4/5 of, that is what I said, right? 4/5 of water, which is 1000. Okay, you're supposed to know this value, density of water and all. Okay, it's standard value. So even like latent heat of water, then specific heat, all these values you are supposed to know. Okay, sometimes they don't provide in the question. So here the answer is 800 kg per meter cube. Let's come to this one. Here we have a capacitor in the circuit. This capacitor C is fully charged. Okay, it's fully charged. Then the current drawn from the circuit. So you are supposed to tell, in this case, since the capacitor is fully charged, what will be the current drawn I the current I drawn from the circuit. Okay, so it's very simple. You are just supposed to know that capacitor, in layman's language, capacitor blocks DC. Okay, so this branch will be short open. Okay, so basically you can treat this as infinite resistance. So resistance is infinite, so the current will not go in this branch. Okay, so this branch you can cut it off. Okay, capacitor is charged, meaning no uh, more current can flow through it. Okay, no more, it can store no more charge, right? It is fully charged, no more charge can flow in that branch. Okay, so basically it opens up the circuit. So it opens up this branch of the circuit, okay, in which the capacitor is present. Okay, now our circuit is very simple. We only have this part of the circuit. You can see that all the resistors are in series. This and this are not in parallel because same current is flowing, right? Series, the definition is same current flows through all the resistors. Okay, so they are in series, all of them are in series. So R effective will be R1 plus R2 plus R3. So 4 plus 7 plus 9, which is this is 11 and 13 and 7, which is 20 kilo ohms. And we can find I as V by R equivalent. So we have V is 10 and R effective as 20 kilo ohms. So we can write that in milliamps, 10 to the power 3, so 10 to the power minus 3, and this is 1 by 2, right? 1 by 2 is half, 0.5 milliamp. So 0.5 milliamperes, option B. Okay, so that's correct. Let's move to the next question now. 19 and 20 over here. In question 19, we have a solid sphere of mass 80 kg and the radius of that sphere is 15 meters. Okay, that huge of a sphere, it is rotating, okay, about an axis passing through its diameter through the center of mass. Okay, so the moment of inertia will be I1 in that case. Then it transforms into a disk within 1 hour of radius 20 meters. Okay, so now the moment of inertia will be I2. You are supposed to tell the rate change of moment of inertia in this process. Okay, so simply I1 minus I2 upon your time taken, which is 1 hour. Okay, so that is what BITSAT is, simple formula application, and then solve the answer conceptually. Okay, so just supposed to link the formula with the concept, and there you go. Okay, so solid sphere, we have the moment of inertia given as 2 by 5 mr square, right? So 2 by 5, so 2 by 5 into m is 80, r square, radius is 15, so 15 into 15, so we can say 5 3s are 15, and 15 3s are 45, 45 2s are 90, 8 9s are 72. Okay, you can do it yourself. It is 7200, and here we'll have half mr square, so half into 80 into 20 into 20. Okay, I can say this is 10, this is 8 2s are 16, 1600, so 1600 times 10, so 16,000. Okay, so the moment of inertia increased, so I2 minus I1 you can do. So you are just supposed to find delta I by delta T. Okay, so 16,000 minus 7,200 upon what? Upon we'll have 1 hour, right? 1 hour is, you can convert it in seconds because we finally want the answer in seconds. So 60 minutes, and 60 minutes is 60 times 60 seconds. Okay, so these two zeros I think can cancel with all of this. So 160 minus 72, 160 minus okay, so that will give us 88, I guess, 88 by 36, right? So you can cancel it by 4, 4 2s are 4 2s are 4 9s are 22 by 9, option D. Okay, so 22 by 9 is the correct choice over here. Okay, so here also we need a simple concept. You're supposed to tell the frequency of this particular oscillation is proportional to, you can see frequency, if you know the formula, it is 1 upon 2 pi under root k by m. Here k will be k effective. Okay, since we have combination of spring. Okay, k effective by m. Okay, or you can remember the time period formula, which is just 1 by frequency. Okay, so you can see that frequency is proportional to under root k by m. So here it is m by k, which can't be the case, it's k by m. So k effective, that is the only thing we are supposed to find in this question over here. Okay, if we know k effective, we know what is the relation between frequency and this how is frequency proportional to spring constant. Okay, so K effective, if you can tell me in the comment section, just pause the video now, what type of combination is this? Is this a series combination or is it a parallel one? Okay, just pause the video and let me know in the comment section. Just let me know with the time step. Okay, tell me the time and comment down. Okay, so 1 2 3, I'll reveal the answer. This is a parallel combination. Okay, it's not series. You might say it is end to end and hence it is series. No, series combination meaning same force on both the springs. Okay, so and in parallel we have same displacement for the both springs. Okay, so if I displace this mass in x direction, okay, by this much, the same extension will occur on the spring and same amount of compression will occur in this spring. Okay, so delta x is same, meaning this combination is parallel, not series. Okay, in series f should be same. Here f will of course vary, but x will be same, delta x will be same. So this is a parallel combination, and in parallel combination we just add, right, 2k plus k, which is 3k. Okay, so f is proportional to k effective, which is 3k by m, okay, which is the mass of the block. So option A, under root 3k by m, is the correct choice over here. Over to the next one. 21 and 22 over here, if you see these questions, these are directly formula based questions. Okay, and in every BITSAT paper that you answer, you will get at least 2 from the physics side. I am saying at least 2 questions which are entirely formula based. Okay, completely, or you just have to use the formula, plug in the values, get your answer. Okay, you'll run into at least 2 such questions. Okay, so it's very important that you learn all the formula. Okay, so those are 6 marks, right, plus 3 plus 3. Okay, let's come to this. Moving coil galvanometer has a resistance and full scale deflection of this. It can be converted into voltmeter of 10 volts full scale deflection by connecting. So in order to convert to a voltmeter, we have to connect a high resistance in series. So if you can actually guess from the options, you can only see this C option as the highest resistance. Okay, among this, these are very low resistances, so that will be the answer. Okay, but anyways we are going to do it by the way, standard way. The formula basically says V by Ig minus G. Okay, so this is the resistance that we are supposed to use. So V is 10, the scale deflection that we want. The full scale deflection current is 0.01 amps and the resistance is 10, right? So here this is 10 to the power minus 2, go on top, become 10 to the power minus 3. So this is 1000 minus 10, I think this should be 990, not 9900. So this is 990 ohms. Okay, I might have copied the question wrong. It is 990, right? I might have copied it wrong on the book as well. So it's 990. Okay, we get 995 by the formula. Let's come to this one. Here we have coefficient of static friction between the rod and the tire is given as this. The maximum velocity that it can go with while traveling along a curve of radius 20 meters, and this Vmax is directly given by mu rg, right, and g, take it as 9.8 mentioned in the question, right? So 0.25 into r, which is 20, times g, 9.8. okay, so here what will be this 20, so 2.5 and times 2, 5 into 9.8, again we can say 49, right? So that will be 7 meters per second. Okay, 5 into 10 is 50, 5 into 9.8 is 49. So option B, 7 meters per second. So direct formula based question, just use the formula, plug in the value, get your answer. Okay, so over to the next one. Question 23 and 24. In 23 we have 2 balloons, one is filled with pure helium gas, other one is with normal air. Okay, it is given that the pressure and temperature of these balloons are same. Then you are supposed to tell the number of molecules per unit volume. Okay, will it be same in both? Will it be more in helium, more in air, or the ratio is 1:4? Okay, so actually we are supposed to use one of the laws, gas laws that we study in thermal physics. Can you guess it? Which one is that? Dora the Explorer vibes. Okay, let's come back. The law that I was talking about is your Avogadro's law. Okay, it says that for a given volume, Okay, so if you have equal volumes of two gases and they are at the same pressure and temperature conditions, then the number of molecules in A will be same as number of molecules in B. Okay, they will have same number of molecules. Okay, equal amount of gases at same temperature and pressure have equal number of molecules. Okay, and you are just supposed to find per unit volume, right? V by V. Okay, so here basically then you are supposed to conclude about number of molecules per unit volume. We said that these two are Na is equal to Nb. Now you just take per unit volume, so that quantity is also equal. Okay, so they are same in both. Number of molecules are same and per unit volume hence is the same. Okay, let's come to this. A proton moving with a velocity of that enters a magnetic field of 0.3 Tesla with an angle. Now it does not enter perpendicularly, it enters with some angle 30 degrees with the field. You are supposed to tell the radius in this case. Now radius of the path, right? It will take a circular path, helical actually. So you are supposed to tell the radius of that circular path. Okay, so r actually are only the perpendicular component of your velocity will contribute. So it enters the field making an angle theta, right, with the field. So this is the field, this is the velocity, theta is 30 degrees. So you can see v cos theta will be along the field, v sin theta will be perpendicular to the field. So only the perpendicular component, which is v sin theta, will contribute. Okay, actually the formula for r is mv by qb. So here v we have to change it to v perpendicular, which is v sin theta. So mv sin theta by qb or eb, because it is proton. Okay, and E by m is given for proton, so we can write this as v sin theta, or we'll directly substitute. V is velocity is 3 into 10 to the power 5, sine of 30 half, and we can take this E by m, we'll take the m in the denominator of E, so E by m is 10 to the power 8 and B is 0.3 Tesla. Actually, okay, so we can say this is 3 into 10 to the power 7, right? We can write it like this, and we'll have half over here into 3 into 10 to the power 5. This cancels. This is 0.5 and this is 10 to the power minus 2, and this is in meters, right? Or this will be 0.5, 10 to the power minus 2 meter is centimeter. Okay, so option B, 0.5 centimeter is the correct choice over here. So over to the next question. Coming to question 25 and 26. In 25 we have been given a circuit. We are supposed to tell what is the value of this current in this given circuit. Okay, now a hardworking student will use Kirchhoff's law only to find that this is a special type of connection, the Wheatstone bridge, and it is the balanced Wheatstone bridge. Okay, so I'll make you see it. Okay, so let me draw it more clearly. I can say A, this is BC, so BC, okay, and D. Now you can see the bridge clearly. So A and B, we have 10 ohm resistor in between them, right? And then B and D, so B and D, we have 20 ohm resistor between them. Then if we consider point C and D, suppose C and D, we have 12 ohm resistor, and now we consider point A and C, 6 ohm resistor. So 1, 2, 3, 4, and this is between B and C. So this is the simple Wheatstone bridge, and if you see the ratio in the branches, R1 by R2 is R3 by R4. If you see 10 by 6, or let us take 6 by 10, 6 by 10 is same as 12 by 20, right? You just multiply it by a factor of 2. So the ratio is the same. Okay, so it is a balanced Wheatstone bridge, which means that this branch there is no current. Okay, this branch is not contributing at all. So we have 10 and 20 in series and 6 and 12 in series, and they are in parallel. Okay, so R effective will be, so 10 and 20. So basically here we'll have 10 and 20 in series, which is 30 ohms plus, right? 10 plus 20, and 6 plus 12, 18, 18 ohm, and these two are in parallel. So the R effective will be product upon sum. right? So 30 into 18 upon 30 plus 18. Okay, so 30 into 18 upon 48. So 6 5s are 6 8s are, and 9 upon, what is this? This will be 9, and this will be 4. 45 upon 4. Okay, this is R effective. Now I will be V by R effective, or R equivalent. V is 10, R equivalent is 45 by 4. So 45 by 4, this is 40 by 45, so 8 by 9, right? 5 8s are 45, 9s are 45, so 8 by 9, so which means it's 0.8888. Okay, whenever you have 9 in the denominator, so that will become 0.8888, so it's close to 0.89. Okay, so 0.89 amperes is the correct choice over here. Okay, you could go by the Kirchhoff method and you'll end up knowing that it's a Wheatstone bridge. Okay, so whenever you have this type of connection, okay, complex connection, see if it's making a Wheatstone bridge, and see more importantly if it's making a balanced Wheatstone bridge. If it was not balanced, you should have used Kirchhoff's law in first place. Okay, let's come to this. An achromatic convergent doublet of two okay, what is that mouthful word? Okay, so an achromatic convergent doublet of two lengths in contact has 4 plus d diopter power. Okay, so that is a lot of heavy language. I'll just explain you simply. So we have two lenses, one convergent, one divergent. They are kept in contact. Their combination is having this power. So we can say P1 plus P2 is simply 4D plus 4D, right? Convergent and divergent. One is plus, convergent is plus, divergent is minus. Okay, so the power of converging lens is plus 5D. Okay, so plus 5, P1 is plus 5. The ratio of dispersive power of convergent and divergent lens. Okay, you are supposed to find W1 by W2. Okay, convergent to divergent. Okay, so first of all, let's find P2. So P1 is given as 5, right? 5 plus their combination is 4. So P2 will be, of course, 1 has to be minus. So P2 is 4 minus 5, which is minus 1. Okay, so we have P1, we have P2. P1 is 5, P2 is minus 1. Okay, now we are told that it is achromatic. Achromatic meaning there is no dispersion of current. Okay, if you have lenses in combination, there is a chance that they might disperse the light, right? So it is achromatic, meaning there is no dispersion of light, meaning we can use the achromatic condition, which is W1 P1 plus W2 P2 is equal to 0. Okay, if it had to if it had chromatic divergence, okay, dispersion, then this would have been something finite. Okay, so here from using this we can find the value of W1 by W2. Okay, so from here you can see W1 by W2, they are inversely proportional to P1 by P2, right? So W1 by W2 will be P2 by P1. Okay, you can see it for yourself. Okay, just solve this, you will get W1 by W2 is minus P2 by P1. P2 is minus 1, so minus minus plus, and P1 is plus 5, so 5. So 1 is to 5. Option C is correct over here. Okay, so let's move to the next set of questions. 27 and 28, the final stretch over here. So the electric potential V is given as a function of distance. You are supposed to tell the electric field. Okay, very simple question at x is equal to 1. Okay, of course the electric field, the voltage is in volts and this is in meters. Okay, so the answers will be in volts per meter. Okay, E, as you might know, is minus del V by del x. Okay, actually it is gradient, but since it is single variable, you can basically directly differentiate. Okay, so let's differentiate this function. If we differentiate 5x square, I hope you know how to differentiate. X square 2 comes down, so 2 5s are 10, 10x, and kx, differential of that is 10, and this is constant, differential is 0. And we are supposed to say at x is equal to 1. Okay, so at x is equal to 1, this will become 10 and this is 10, so 10 10 20, right? And this minus sign, so minus 20 volts per meter. option D. Okay, very straightforward. Use the formula, get to the answer. Okay, let's come to this one. Here we have a charge plus q which is at a distance L by 2 from a surface, okay, square surface of length L. Okay, this is of length L, square surface. Okay, you are supposed to tell what is the flux linked with the surface. Okay, the charge is like L by 2 and the surface is like this. Okay, so the surface is like this, the charge is here. Okay, half the distance of the length. Okay, and this is a square surface. Okay, so let's come to this. So actually we can imagine first of all for a cube of length L. So for a cube of length L, this charge inside, what is the flux linked with this cube? It will be, flux will be q upon epsilon naught, right? Now only due to symmetry reasons, since this q is at a distance of L by 2 from each of the face, right? So in our case, okay, if we consider uh, if we consider one of the face, we can see that this q is at the distance of L by 2 from each of this face, right? So the flux linked will be 1/6 of the total flux. Okay, 1/6, because there are 6 faces. Okay, 6 faces, and this flux is linked symmetrically with all the 6 faces. Okay, if this was not L by 2, it was somewhere else, we could not have concluded. Okay, if this was closer to the surface, okay, then the flux would have been more. Since it is symmetrically placed at a distance L by 2 from each of the surface, each face, which will be the sheet in our case, will become 1/6 of the total flux. Okay, so due to symmetry reasons only, we get the answer. Flux through our surface, phi dash we can call, is q by 6 epsilon naught. Okay, if this was not L by 2, the case would have been something else. But even the interesting thing is, so even in the cube, if you have the charge over here, okay, it's not symmetrically placed, but it's inside the cube. Okay, here the flux still would have been q by epsilon naught, charge enclosed upon epsilon naught. Okay, but here the flux linked with a particular face would have been very different. Okay, so in our case there is symmetry, so we can say it is 1/6 of the total flux. There are 6 faces, so it is distributed uniformly among the 6 faces. Okay, so that's about question 27 and 28. Let's move to the final question for the day. 29 over here, the last question for the day. What happened to question 30? Question 30 is your homework question. Okay, you'll let me know the answers of that question. So for now, let's focus on this question. Question 29, a maximum of 3 Newton force can be applied on a block on an inclined plane. So this force is down the incline. So this is a rough inclined plane, meaning there is friction at action. So friction at action. Wow. Okay, so here in the first case, we can apply a maximum of 3 newtons without the block moving. Okay, so the friction can support 3 newtons force down the incline. Also, the maximum external force then that can be applied above the incline. Okay, in the direction up the incline is 12 newtons. I think, yes, 12 newtons. Okay, again 30 degrees. So you are supposed to tell what is the coefficient of static friction between the block and the plane. Okay, it's very easy. It's again equilibrium, so keep calm and balance the forces, solve the equation, and just like that you'll get your answer. Okay, so let me solve it over here. I took too much of space, being excited. And now in the first case, we can say that along the incline, what is the force? Mg sine theta, right? Always remember that along the incline, down the incline will have mg sine theta, and up the incline, sorry, perpendicular to the incline will have mg cos theta. Okay, along the incline, mg sine theta, and theta is the angle of inclination. Okay, and here we'll have mg cos theta. Okay, and this is balanced by friction. Okay, of course, right? So that's why the block is not moving. So it can support mg sine theta plus 3 newtons. Okay, this can be balanced by the force of friction mu n. Now what is the normal force? Is it mg? It's not always mg. Now sine theta we can substitute. Sine 30 is half plus 3, and what is the N over here, N will be normal force, right? Perpendicular to the incline, it is mg cos theta. It will balance this force, right? So N is nothing but mg cos theta. Okay, I'll write it, cos theta is root 3 by 2. Okay, so this is our first equation. Okay, and for the second equation, we can use that. Okay, here you can see again mg sin theta along the incline, down the incline. This is mg cos theta, and now the question is, in which direction will friction act, right? So if you see, you are applying the force in the upward direction. Friction opposes the motion, right? Friction opposes motion or a tendency of motion. Okay, so it will oppose motion and it will act in the downward direction. Okay, so be very careful. See in what direction you are applying the force. See the tendency of motion. So the motion, if you apply a force greater than 12 newton, 13 newtons, it will move upside, right? So the friction will act in the downward direction. Friction opposes motion or the tendency of motion. Okay, so friction will act in the downward direction in the second case. So mg sin theta, so mg sin 30 is half, and mu n, so mu n is again mg cos theta, so mg root 3 by 2 is nothing but 2l. Okay, this is our second equation. Okay, both are correct. So actually what I can do, I can get this over here, I can modify this equation, since when I add, will cancel that. So this is our equation 1, I'll say, and that is our equation 2. If I add 1 and 2, so basically I am solving now. Okay, you can use the elimination method, that is what I am doing. So if you see, this and this term is same, and when you add them, they are negatives of each other, they will cancel, and mg by 2 will become mg, half of 1, right? No brainer. And this is 12 minus 3, right? We are adding, right? So 12 plus minus 3, so which is 9. So we get mg as 9. Now we can substitute mg as 9 in any of the equation and obtain mu. Okay, so that was the objective over here. Can we substitute it over there? We can. Okay, so okay, we'll substitute it in this one, and doesn't really matter. So here 9 by 2 minus mg is 9 by 2, right? Sorry, mg is 9. So here also mu 9 root 3 by 2, and here we'll get minus 3. Okay, so we can bring this 3 to the other side. Let me solve it over here. So 9 by 2 plus 3, and we'll have mu 9 root 3 by 2. Okay, so 2 and this is 16, 15, 9 root 3 by 2. This 2 and 2 can get cancelled, and what do we have? We have mu is equal to, also this can get cancelled. Let me solve it later. So you can cancel with 3, 3 5s are 3 3s are, right? 3 3s are 9, 3 5s are 15. So 5 by 3 root 3, is that an option? No? Or option B, yes, 5 by 3 root 3. Okay, so that is our answer. You just had to keep calm and balance the forces. Okay, keep calm and balance the forces. Okay, in the first case and in the second case. Okay, use two equations, eliminate them, find mg or m, and then substitute in the one of the equations. You will get the value of mu. Mu is 5 by 3 root 3. Okay, so that's about this session, and the last question will be your homework question. Okay, question 30 over here. You can pause the video over here and take a screenshot. This is your homework question. Okay, and this is based on principle of calorimetry. Do try it and do let me know the answers in the comment section. The correct answer receives a heart from me in the comment section. And that's about today's video. I hope you really enjoyed it. I hope it was really fruitful. I hope you will join me in the next session, which is going to be next week, okay, wherein we'll discuss 30 more most probable questions for BITSAT 2022, and we'll continue this grind for a few more months, and we'll see us growing stronger. Okay, so that's about it. I hope you enjoyed today's video. I'll see you soon in the next one. Till then, keep enjoying physics.